That's
Cool.
fine.
All right, cool. Recording. All right. All right. So we have the old humble atomic clock here, and here's a great video to if you want to like learn more about it or whatever, but I'll give you the quick TLDR from the video. Oops, that's not how you copy paste an actual link. Anyway, I'll get it here in a second. But anyway, here's the atomic clock, and then when you crack open this bad boy, it's about what's going on in this vacuum chamber over here. So when we look at the diagram, we have a cesium oven that gets heated up and it emits cesium gas, cesium atoms that's been heated up from the oven. And it hits a magnetic field here that's set to a specific strength, you know, and that field will bounce out any of the cesium atoms that are excited at a rate that's higher than, 9,192,000,000 oscillations per second. So like a, what do they call it? 9.192 gigahertz. So that specific frequency is what the clock is tuned to, the natural oscillation rate of cesium. So anything that's above or below that gets bounced out. Anything that's of that frequency goes through that magnetic field, gets sent into this ionization chamber here, where radio frequencies are introduced to the cesium. And once they have a radio frequency that matches the cesium, and they're able to bounce off of each other, you know, and have that matching signal, they exit this microwave chamber here through another magnetic field that maintains that same rate. So anything that's above 9.192 gigahertz gets bounced out, and everything else of the appropriate frequency gets sent over to an ionizer, which it just ionizes the gas in the radio waves, and then that converts that into an electric signal. That signal gets amplified over here by the photomultiplier, and then that gives them like a pulse rate. So that's how they convert cesium into 1 billionth of a second, essentially, right? That's how they make this. So this is how they take 1 second and divide it into 9,192,000,000 of a second off of this rate. So they convert the energy here into electricity into a specific rate, and that's what they're using to divvy up time. Now, when you have a stationary clock, this stays more or less in sync, right? But there's also periodic shifts. The guy that made the atomic clocks, his name was Louis Essen, and he noted that sometimes these randomly go out of sync. But the reason that it's so accurate is because it's so easy to correct and maintain through this system, because once you have the frequency locked in and it matches, and your output is, you know, at the correct 9,192,000,000 of a second, you basically lock it in, and then it just maintains this on a cycle, like on a loop. And then if there's any deviations, they can just make corrections, no problem. So when they get into using this to keep time, right, the theory of relativity predicted that clock synchronization should be done a certain way based off of Einstein's theory and the constancy of the speed of light. And basically what the process is for syncing a moving clock to a stationary frame, you would have to do a half timing offset when the clocks intersect at a specific time. And this half timing offset would be based on the logic that the speed of light is the same for the one way that it is on the two way. And while that's true for the most part, you can actually do what's it called? Phase conjugate mirror interferometry, and which is like a special mirror that preserves the wavefront. And you can actually see that the one-way speed, the wavefront is already changed. So anyway, this is based on the assumption, though, that it propagates at the same speed. So they do this half timing correction, and it works for a little bit. It works in some cases, and then it starts to desynchronize as the clock continues to move. So what they found is that they actually have to add an additional SAGNet correction to it based on the clock's velocity. So whatever vehicle is moving the clock, there's a retardation that's proportional to that. Now, in some cases, like on a plane or in a car and whatnot, the natural corrections of this already take care of that kind of stuff. But at faster velocities, it starts to lose time where it's like an issue or whatever. So what they found was, and over long periods of time. So what they found was when they did the Heffel and Keating experiment, they had these predictions based off of Einstein clock synchronization on this half timing correction, and that it would basically balance itself out to always be in sync once you get it going. But then experimentally, they found that they had to keep making different corrections, and this method actually didn't work. And what they're syncing everything to is they're basically just doing timing offsets, and then they're doing SAGNAC corrections, which are first order timing corrections, not relativistic second order link contraction, time dilation type corrections. But we'll get to that as we move into the experiments here.
Do you mind if I ask a question?
No, absolutely.
Oh, wonderful. I just wasn't sure if I was supposed to interrupt or not.
No,
Is
anytime
this
you have a
based on
question, you're
speed
good.
or elevation specifically?
So we're going to cover the speed first, and then we're going to get into the gravitational potential corrections as well, because that would be for the altitude stuff. But the purpose of this is to show the overall mechanisms of how it works, because the distinction made is like people act like there's two different type of corrections that are being made and stuff, or like you would be able to distinguish it. But what's actually mechanistically happening, like, you know, per the internal processes of the clock, right, is there's it's just like this oscillation rate is oscillating slightly slower, right, or faster depending on, you know, altitude or movement. And that's really the issue here. But yeah, since you brought that up, we'll quickly get through the speed here. So for Heffel and Keating, for the special theory of relativity, they were predicting that there would be time dilation with respect to the stationary clock. And what they showed experimentally was that the clocks were off by several orders of magnitude, and they were off because they went clockwise and counterclockwise. So each set was supposed to have a specific amount of retardation or boost to the time, and none of it matched. Like, it was all out of order. And in the original debriefing in 1971, they were like, yeah, the error between measurement and experiment is pretty damning, and it wouldn't surprise me if nobody is convinced of this or whatever. But anyway, they did some mathematical corrections that they don't even ever show. And then in 1972, they published that this is proof of time dilation. But that's actually a separate issue with the twin paradox. So we only have like a one-way confirmation of this. But then anyway, what this later turned out to be, and what they actually account for, is the SAGNAC effect. So just the relative motion of the clock through a field has a directly proportional velocity, or has a directly proportional retardation in the timing. So literal SAGNAC effect, which isn't supposed to be occurring for a satellite that's in free fall around in a gravitational well. But nevertheless, anyway, we'll move on to the altitude ones now. So we have here.
Alan, can I have a question?
Absolutely.
So, are you saying that the time is like dilating? The time dilation is like from west to east and vice versa, and like not from to north to south and vice versa?
Yeah, so there is that issue as well, but that's a separate correction, because they do say that there's a quote unquote velocity correction for Earth rotation, but it's an east-west bias that's accounted for, no north-south, like you were saying, but that's actually separate over the atomic clock issue. That would be more like the signal propagation for GPS, like for trilateration.
Nice, thank you.
So,
yeah, go ahead.
so what you're saying, pardon, it sounds like not only speed is a factor, but direction?
Yes, absolutely. Specifically direction in the north-south. I'm sorry, east-west.
That would correlate with the magnetic field that we've been talking about, right?
And the ether wind.
Sure.
Yeah.
If you want to go with that.
Yeah, either one, north-south would be perpendicular to the flow, right? So either one, I guess. Let's see. I'm sorry. I'm looking for the gravitational potential part of this. Okay. Yeah. So from the experiment from Pound-Rebka, going back to gravitational redshift, which is like the frequency shift in electromagnetic propagation due to the gravitational potential. So meaning closer to the Earth, the stronger gravitational gradient. So there's going to be more of a frequency shift as you get further away. There's going to be less strength, so you're going to experience time faster because you're going to be able to move more freely or whatever. So that's how they look at it. In 1960 and 1965, there were 2 experiments done, Pound Repka and Pound Snyder, where they were using gamma radiation. And anyway, they measured this predicted frequency shift in radiation based off of a difference in altitude of 75 feet from the ground. And the detector that they were using was a Mossbauer detector, which, similarly to how the atomic clock has an ionization chamber that ionizes a specific frequency and converts it into an expected signal amount. That's what that detector does. It doesn't actually measure like wavelengths or anything. So it just has like an expected amount. So this device, this experiment, can't tell us if the speed of light is constant and experiences a frequency shift and wavelength shift that are inversely proportional while maintaining a constant speed, or if the speed of light moved faster, falling down as if it were affected by 9.8 meters per second squared, and it fell equivalently faster the same way like a BB would or something like that, instead of falling at a constant speed. So the mathematical outcomes for the classic theory and the relativistic theory are the same, but this detector, unfortunately, can't tell us the difference because it doesn't measure wavelengths, or so we don't know the phase difference, in other words. But anyway, when they get into atomic clocks, what they say is that we have to introduce these gravitational potential corrections. And they say that the Earth is a oblate spheroid in rotation through a gravitational field. And I'm guessing based off of that, they assume a gravitational field is fixed, because the way that they word it is that the Earth, being oblate, rotates through this gravitational field. And because of that oblateness, there's actually like an equatorial offset between the equator and the North Pole, such that they can actually just use a uniform gravitational correction and treat it all at the same altitude, even though it wouldn't be considered that way on their model. So they have this. So for each satellite system that's at whatever orbit, they all have like uniform corrections that they apply. And then when you so anyway, mechanistically, long story short, right, gravitational field or ether wind is the contention for the reason for the corrections, right? Because for ether wind, for the velocity corrections, right, your relative motion through a field will cause retardation proportional to your velocity. So that's just the basic Sagnac effect. So that would be like mechanistically what's doing that for velocity. And then for altitude, what was measured experimentally by several people, Yuri Galev, and who was the other guy? Who was the other altitude lad? Dayton Miller. They found that when you take an interferometer and take measurements, the velocity of light increases at altitude. There's a vertical velocity gradient. So if there's a translation of motion from the sky in the form of ether wind, these two theories would make the same prediction in terms of quote unquote gravitational potential corrections versus a velocity gradient correction. These are all equivalent, and there's no distinction between them. And actually, the equation that they use for them is they don't even use relativistic physics in any of these in GPS. They use they use equations that are equivalent to the classical Sagnac effect. So they're only making like velocity and light corrections with respect to absolute space and time, rather than relativistic corrections of the second order for link contraction and time dilation. These are like first order proportional corrections for velocity, and that's really it.
That's actually very interesting. So what you're saying is the ether wind is the reason we're getting these readings.
Yeah, if you take the position that the Earth is stationary, any type of motion measurement regarding light or pendulum precession, etc., would have to be facilitated by that mechanism. So, I that's what facilitates it for everything. That's what causes the precession of a pendulum. That velocity gradient. That's what causes gyroscopes to measure 15 degrees per hour.
Foucault as well.
Yep.
And would this work on anything but a circular Earth, or would this work on other models, other shapes?
No, this would work on a globe. This would work on a flat Earth. This would work on a pyramid, right? Any of those, it doesn't matter, because like mechanistically, all we have measurements for is this east-west bias that I was talking about earlier. So anything that can, anything that has something that could rotate around it, you're good to go, essentially. Like however you want to conceptualize it, there's like no restrictions on that. And in fact, a lot of the research that I pull from for ether dynamics, primarily a guy named Matsutovsky, he's a globe lad. So his conceptualization of it is that there's like a cosmic ether that flows into the Earth, and it creates like this turbulent and laminar flow situation that provides the bias as the Earth rotates through it. But if the Earth is stationary and fixed, then mechanistically just the ether does the motion part of it. So that's like really the only distinction. And then in terms of shape, doesn't matter. You could impose different assumptions to make it work on any shape. It doesn't matter.
Very interesting. So that light, I assume, is the sun?
Come again?
The light that I'm looking at
No, that's
on your image?
no, that is the, oops, sorry, closed it. That was just the orbital path of a satellite.
And the satellite would work with the ether wind, is that right?
Yeah, absolutely. Actually, speaking of satellites, let's take a look at this really quick, because this is really interesting as well. 1 second. Take a look at their orbital paths. Now they say that these satellites are in free fall around a gravitational well. Like that's the general theory, maximum high tier academic understanding, right? And they would call that an inertial frame. And in an inertial frame, if relativity is true, which is the current supported paradigm that they say, GPS is proof of and only works because of relativity, etc., then these satellites in free fall around a gravitational well should not have velocity dependent corrections, because it's like what external reference is it making to have its own velocity retard proportionally like that. So that in and of itself kind of tells you that their conceptualization of free falling around a gravitational well is at least wrong. But then further we could look at the orbital paths, right? So they always show us these equirectangular projections of satellite orbits for all their publicly available data, which looks like this. This is the equirectangular projection. They show us the nice sine wave. And now we're going to look at a couple of things here. So this coordinate system, this latitude and longitude system is invariant under projection transformation. So it doesn't matter if we're looking at a globe, an equirectangular, or an azimuthal, as long as you use the correct transformation and corrections, which is like a directional preserving aspect of the transformation, you can transform these and you can see what they'll look like on the different projections, and they'll all be equivalent, right? They'll all represent the same thing. So on a ball, if you're on the North Pole and you're coming down the ball and then you come up on the other side, this is what this would look like on a globe. Down, up, right? Down, up. So globe, equirectangular, azimuthal projection. This is what it would look like if you were going up the ball and then down the other side, and then you would magically come up on the other side to go up and then back down. So all representing the same thing and accurate and true to the coordinate system that it is plotted on. Now, when we look through the publicly available data and we transform it to an AE map, all we get are giant figure eights in the sky that make flower of life patterns. So none of these substantiate north-south orbital paths, which is like touted to be, proof of the shape of the Earth in relation to the coordinate system that's being used and all of that. Yet when we look through all the publicly available data, not a single one of them actually go circumpolar And then when we do terrestrial routes as well for planes and boats and stuff like that, where these people are said to do north-south circumnavigation, none of these routes represent what they claim to represent. And the One More Orbit crew was actually called out on Twitter, and then the guy replied and was like, oh, you know what? The marketing team actually put out a conceptual route. That's not the real route. So, don't worry or whatever. But yeah, when you go through and transform any route where they have stated that this is proof of north-south circumnavigation, none of them show the proper corresponding transformation. And in fact, it was kind of funny because nobody knew what this would even look like. We had to do some investigating on it because no one's ever even seen this before, this kind of this representation of it, which is what would be required or whatever. They always show us this one. So whatever's going on with satellite. Oh yeah, and another thing. So check this out. Another thing with satellites, right? So the orbital diameter that they have is 20,000 kilometers in altitude, they say, right? That's their altitude. Now, if you take that and put it as a 20,000 diameter circle around the Earth, around a Gleason's, the timing offset for the corrections would be identical, and you would never know the true altitude of the satellite, right? Because the thing with these satellites is that they obey Kepler's laws in the sky, right? So meaning you could take the periodicity of how long it takes the satellite to clear the sky and then come back to you, and that will correspond to what they would say are the same parameters that they would use for a GMM over R squared, which would be like the Newtonian gravitational way that you would predict the gravitational relationship between Earth's mass and the satellite. But in that equation, the mass cancels out and it just becomes a ratio of the periodicity over a constant, which always gives the same result. So the fact that they're equivalent or whatever doesn't really tell us anything about the mass or the actual correctness of the orbital mechanics, because it follows Kepler's laws and it's just a ratio of the periodicity, what that could imply, right? Like how I was saying earlier, because the orbital altitude and if you just use it as a diameter over a disk, they would be the same. What you would have is the satellites would clear the sky in the same amount of time, but they would just be closer to you and they would be just moving slower than what we're told. But because of that distance relationship and the scaling, they would be the same. And then because of the corrections for the coordinate system to make it all match and synchronize, you wouldn't know its altitude offset anyway. But everything that you get from it, based off of those parameters and timing, is all going to match. And that's exactly what they do. What we found was they actually make, we talked about the SAGNet corrections that they make. Well, every time a satellite passes 2 ground stations, that makes another correction just to further ensure that it's on the same time that it should be, because the whole thing is based off of timing and the speed of light for the baseline. So if you have like the lead way to make those kind of corrections to it on the back end, everything that you send out would like appear proportional to globular distances and altitudes, but none of it would have any actual relation to that. It would be just at a different altitude and moving slower, but it would still scale proportional.
If you don't, Alan,
Yeah.
if you don't mind.
Mm-hmm.
So what you've proposed, it tells me that everything up there is lower and slower, but it's up there. And no one would really know outside of very, very few, maybe powerful people, but no one would really know what was going on because they'd assume they were going around a ball and they couldn't tell otherwise. They see about 3% of the Earth from the ISS. So they would keep making these satellites and the satellites would keep working and everything would be fine. But it doesn't have to be the grand conspiracy that everyone's talking about. You've stated that satellites work just fine and that the ISS would work just fine, and everything that's up there, it makes sense. Now, how is it following this ether wind? How is it making these,
Ooh.
these little figure eights?
So great question. Mechanistically, like you were saying, how only a certain amount of people would know like the actual propulsion mechanisms for satellites, etc. That I don't know. I've got some speculation on it. So there's basically, if you look at a ferrocell and you see the magnetic flux lines, you'll see that they share a similarity to these flower of life patterns. So there could be some relationship there with utilizing the magnetic flux and magnetic force lines. There could be electrostatic tethering. There could be, are you probably not familiar with it, but it's called the Byfield-Brown effect, which is some vacuum capacitor polarization thing. I don't fully understand, but apparently you can use a capacitor in a vacuum to generate more lift than you should. And there's like examples of it on YouTube called, they're called lifters or whatever. Like the little people do experiments with them with triangles made out of foil or a foil triangle, and then like they can get it to lift or whatever. But there's like a more grown up version of that when you do it in a vacuum and with certain equipment and stuff, you can actually get an increased effect that would be that they were talking about how that could be used for propulsion mechanisms in a vacuum and stuff. 1 second. And then that research seems to be pretty guarded / not publicly available. So I don't know the mechanism, but all I know is that with the timing corrections and everything, it would be, I mean, that would be easily viable. So I don't get caught up on the mechanism.
Now, would this field have visual distortions as well if you were looking down on it?
I don't think so.
So the field doesn't create any visual distortions when we look up at it, or if you look down on it?
I wouldn't attribute anything to it like, oh, I'm looking through an ether gradient density. I would never state that personally.
Okay. No, that's great. Carry on.
No, that's about it. That's where I'm at with satellites and atomic clocks and relativity and ether effects versus relativistic effects, etc. So if you have any questions though, feel free.
I would say,
No,
hey, mention
it's
something
great.
about Dayton. I would say mention something about Dayton Miller and his stats because Aeon before you were here was mentioning that she thought they should be kind of thrown out because of them being either ball believers or anything that they might have actually included it pertaining to the ball or
Well,
Yeah,
a measurement
yeah, that's
of
right.
a
And then
measurement.
Riggs explained that it would be reinterpreted through the lens of a planar, non-rotating Earth.
Oh yeah. Yeah, so mechanistically, right, all they have is a measurement of a difference in the speed of light. They have, like, that doesn't tell you anything about shape or anything. All that tells you is an exact velocity amount, really, right? That's the one thing that it does tell you. It tells you a velocity amount. Now, that velocity could be, a ball, could be on a plane, doesn't matter. It's just, you just think of like an east-west velocity gradient, moving over you. And then that's all it would be. It would work on either situation. Now, in particular, though, it's extremely damning for the people that believe in things like heliocentrism, because the Earth has to be moving at a specific velocity for it to be valid for Kepler's laws and all that, and which would be equivalent to Newton's and all that. So they need a specific velocity of 30 kilometers a second, and every time they would take measurements, they would measure a velocity that was much smaller. They would measure like 6 to 8 kilometers a second at like 200 feet above sea level, which is unacceptable for them because they need 30 kilometers a second. And what they so they started saying like, oh, we'll just round this measurement down to 0. But as it turned out, 6 to 8 kilometers was actually outside of their margin of error, meaning it's like has statistical significance to it. So, so with that said, they had proposed to do more experiments throughout the year to see if they could figure out if, like, how they say in the heliocentrism, the Earth will be based on its position around the sun, that it'll be traveling at different velocities slightly. So they were proposing that based on the time of years when these velocity shifts would be occurring, they would take more measurements and stuff. And then they never ended up following up on it. But another guy picked up on their work and repeated it. And then he actually started doing the measurements at altitude as well. And what he found was on the equinoxes, they do receive a shift. Like it does get faster and slower. And it reaches the maximum amount of how fast it gets throughout the year, and the slowest on the equinoxes. And so what he showed was that there's like an annual periodicity for the sun and a stellar periodicity for the stars, because when you plot the dimensions of the minimum, like the peaks of the minimum and maximum speed fluctuations, when you plot that against sidereal time, it makes a sine wave out of the graph. So they took that as like good causation correlation, that they were measuring, stellar time and annual time, but the velocity component was just not there for them. And because of the nature of the measurement, it's exact, and they can't be like, oh, it's only 7, but trust us, it's 30 kind of thing. So they had to throw out everything and say, no ether, and kind of demonize it and everything, and make it appear as if all motion's relative, and you can't tell with with any sort of absolute frame mechanism or any of that. But all of that's completely false, and that's what's been covered up through tons of scientific fraud.
Yeah, no, and it makes sense. So it sounds like what happened was people began to assume they were on a sphere. They began to assume the sphere was moving. And anything that went against that, they weren't willing to throw away the sphere. So they just kept band-aiding it.
That's exactly what happened.
Yeah. So it's not a nefarious conspiracy. And, if we're talking about it like this, it's a very rational thing to understand. Yeah, everyone assumes we're on a sphere. We won't throw that away. Everyone assumes we're spinning. We don't want to throw that away. So everything else that we see has to be wrong. So we have to band-aid everything to make, our ball and our spinning ball work.
Yeah. Yeah, that's basically it.
Yeah.
Started with what was it? Celestial navigation, when they imposed that spherical coordinate system on us, and then they built a cosmology around it, and they were like, well, the reason this coordinate system actually works and is so accurate is because the Earth's actually a ball. And everyone was like, oh, dope, cool, even though the ball is just one of the projections that the coordinate system makes, right? But then they were like, you actually live on this. And then they all have a specific philosophy, and by all I mean the people from the Royal Society, which is what our history is handed down from. So like all these experiments, all this documentation on ether and light and how everything works, all comes from the Royal Society, and they all had a specific philosophical bias. They were all adherent to the Copernican principle. So the idea that the Earth's in motion and all that, and they were all super excited about the relationship with Newton's laws and Kepler's laws, and using algebra to ratio those out and show that, to have like explanatory power of the heavens, man, they were just on cloud 9, so they could never give any of that up.
Yeah, I have to ask about the celestial navigation, because I had a Globie bring that up to me. He said, oh, well, celestial navigation proves that the world's a globe. Very interested in how they get that.
Yeah. So what's given to us is from the Nautical Almanac. And what they did was basically, if you think of the night sky, like a snapshot of the night sky at a specific time. So on the vernal equinox specifically, that night, you take a snapshot of the stars, and you use that as your reference point for all future nights, right, throughout the year. And what you do with that original snapshot is you go around and you take elevation angles to stars. So basically you just do, you follow cosine trigonometry, right? You just take an elevation angle, and then based off of that angle, there's a ratio of that will be the baseline of that angle will be the distance, right? So they'll take an elevation angle to a star, they'll cosine it out, follow that distance out. And by the way, all distances, all units of measurement, so like miles, kilometers, etc., meters, are all fractions of the latitude and longitude coordinate system itself. So that's why you can take an elevation angle to a star and it comes out to be, using cosines, you'll get like a distance, like, whatever, 300 miles or something, right? Let's say. And the reason that you can walk that and traverse that and count it up and it comes out to be exactly as predicted is because it's all a ratio of the system itself. So it would be useless if that didn't work, right? So the ratio relationship alone doesn't tell us like any true dimensions. It just gives us the baseline to work with and to be useful to understand. It doesn't mean that, right. So anyway, they take their elevation angles, and then they traverse the land, and then they're directly underneath that star eventually, right? And when they use a theodolite or telescope, when they look up, that star should be exactly in the center of their theodolite or telescope based off of the law of cosines, because we're doing 90-degree triangles. We have an exact distance. We have an exact angle. So when we traverse this distance, we should look up and this thing should be directly underneath us when we level out this telescope. And what they found is that it's never directly under the telescope, no matter how hard they do. So they came up with, because the coordinate system, because this system requires like a baseline reference for accuracy, what they did is they started denoting everything as like, okay, this is where the true position of the star would be, in completion to the 90-degree cosine triangle relationship. And then they have the actual position of where it's at, which is its apparent position, they say, right? And then based off of the corrections between the two, you can accurately use the apparent position to determine locations, but you just have to apply a couple corrections. But what they started doing, though, is they started telling everyone that the amount of corrections, like the amount of deviation, was actually due to the Earth being shaped as an oblate spheroid. So this is where that term oblate spheroid comes from. Like we've all heard it, but it's like, what does it mean? Who measured the oblateness? Well, the oblateness comes from the deviations of the predicted positions of the stars when they took their first pass through, when they were, confirming the almanac and confirming the usefulness of the latitude longitude system. Because by royal decree in 1776 by the King of England, he was like, we're going to use this coordinate system now, and anyone that's not using it gets fined $30, which would have been devastating for people back then. So anyway, everything was coming down as like, this is the new thing moving forward, and everything is going to be invested in coming up with corrections and making this the most viable way to navigate the lands and the sea. So anyway, that was the first set. So that's where we get the ellipsoid model from. And then they took that reference ellipsoid model, and then they started doing more precise surveying, where they did what's called arc of the parallel measurements, where they basically traversed the entire continent of America, the entire United States, and take measurements in sections horizontally, and then compare them to positions of the stars, like I was telling you earlier. And what they found with like more accurate equipment and precision and timing and methods of telling timing with respect to the positions of the stars, they found that they were off a little bit more, and they needed to make even more corrections. So they came up with this halfway through the arc of the parallel measurements. They came up with a reason for the corrections, because they kept measuring everything as being sub 180 degrees. It would come out to be like, 179. So they were like, okay, well, we know we live on an ellipsoid. So how do we get to, we need to get over 180 degrees here. So they came up with a further deflection of the vertical correction, which is a correction for a gravitational potential. And they say that when they go and take these star measurements and they're off, that it's actually due to there's a gravitational anomaly in their area, and the plumb bob isn't going directly towards the center of the ball. So they have to physically tilt their apparatus to correct for that. And they just call that a deflection of the vertical as well. And, due to a gravitational anomaly. So they just have compounding corrections up to 30 arc seconds in like Australia, for example. Like Australia has the worst corrections, which is what you would expect if you were trying to change sizes and positions of land masses to fit a coordinate system for timing. That's where you would expect it to be off the most. And that's where there's the most corrections. So anyway, they just made up a bunch
Alan,
of
I have
stuff
to.
basically.
Yeah, they did. Alan, why is it that every YouTube channel I look at, it's nothing like this? You know, it's not information like this. It's not presented like this. Why is it Flat Earth looks stupid when what I'm listening to here is not stupid at all? It's the very antithesis of something that is foolish. And
I don't
is
know.
there a way for us to get this type of content on YouTube and other platforms?
Yeah, support Alan and support Shane, and that's it. It's like the best guys here. Nobody better than them.
Yeah, I think everyone's
I'll
doing
be
their
honest, I
best.
haven't heard that type of discourse from Witsit, but perhaps I haven't observed his channel enough.
Yeah, I
So,
don't know.
Alan,
Yeah, I don't know.
what's your opinion?
I do weekly streams and put out information like that. So I don't know. You can only have control over what you put out or whatever. I'm sure everyone's trying their best or whatever. So there's my channel.
Yes, of course. Yeah, no, it's fantastic. It's great information. It's very informative. And I think if we all phrased it this way, if we all started saying things like, cut the conspiracy angle, stop with the Mason stuff, stop with all the 666s and everything like that, and push this type of content and say people just got it wrong. You know what? You've just been putting band-aids on this and actually discuss the science. I think we get somewhere.
How long are you Ian in this topic?
Pardon?
How long are you in this topic? How long are you interested in? I would say physics and flat Earth.
I was, of course, a globe earther for most of my life, and I worked diligently to understand that model better than most people my age and just most people. So, I don't know, I guess you could say 30 plus years. So, Alan, I think.
You are looking to the flat Earth for 30 years.
No, not the flat Earth. No, that wouldn't be. You said science and physics.
Yeah, but about a flat Earth, about relativity and stuff like that. When you start learning about this topic, I'm sorry, I didn't express myself.
I first heard about flat Earth from a person that worked with me in one of my jobs, and then I heard about it on the mainstream news. And of course, because I was psyoped into the idea that it's stupid, it's ridiculous, it's archaic, it's